Ready to where we're gonna be.
Yeah, rock on. Well, hey, the red light is flashing. We are recording right now. So
There we go.
All
everyone,
right.
game faces right now.
I hope this is
Well,
actually part of the recording.
this absolutely it is. It is. Welcome, folks in isolation land. Welcome to another episode of Guest Rose 2.0, the virtual edition. So we are pleased to have dual guests today, and we dropped Justin because his the feedback from the viewers was just he needed to go.
To go. Voted off the island. Yep.
Exactly.
Sorry.
But special treat today, and we're really excited to make this happen because it's been a long time coming. But we're with Nell Campbell, she's the director of soil carbon science here at Indigo, and with Stefan Kemmerling, the senior director of engineering on the carbon platform team, and we'll get more into those teams and what they're working on because it's amazing stuff. And but for the folks at home, well, I don't know, we'll do some quick intros. And I mean, Nell, expand a little bit more on who you are and what you do here.
Yeah, thank you. It's great to have this opportunity to try out my first podcast experience. So I am, I made a switch from academics into business. And that's how I ended up in the director position here at Indigo. Prior to joining Indigo, I actually had no thought that I would end up in a startup environment. So it's been a pretty major switch, but an exciting one because my prior life in academia, I was at Colorado State University for my PhD and worked as a postdoc, then was at University of New Hampshire as a research scientist, but splitting time in Brazil doing work as a visiting scholar at the University of Campinas, which is a little bit outside of Sao Paulo. And was doing work in modeling bioenergy, cropping systems, and then looking at pasture systems and rotational grazing and mixed crop livestock and all these things where you spend a lot of time thinking about soil carbon, greenhouse gas emissions, and how difficult it is to handle all of the data needs around agricultural management to do large-scale modeling for example, doing carbon crediting in agricultural systems. So between my kind of research trajectory and some work that I did on the way, I got to the point where I realized that you really need a business focus to overcome these major challenges in actually doing a carbon crediting program. And that at the foundation are these huge engineering problems on handling models and all the data that you need to run models in this type of situation. So it's kind of amazing then to find out about the director position, because actually somebody within Indigo let me know that there was a search for it. And I looked at that, director of soil carbon science, and I was like, oh, this is exactly what I've been thinking about as like a need. So that's how I ended up applying and coming into Indigo and basically making the choice to switch out of academics for a while to try to see if we could build this thing.
Love it. Okay. All right. Stefan, who are you?
Yeah. So interestingly, my journey almost is coming from the opposite side of this compared to Nell. So I'm definitely coming much more from the tech and software side. I've been through a number of more traditional tech companies, just building consumer software in various ways, from a few small startups, some that did well, some that really kind of went the way of the dodo, and a couple of sort of bigger companies to then come to Indigo, knowing absolutely zilch about agriculture or anything related other than, what a farm looks like and whatnot. I'm from a fairly rural area, but I never really learned anything about, agriculture in any kind of depth. So my learning curve was somewhat steep on like trying to understand how does farming actually work and how do we fit in there, and like does somebody who grows crops for a living think about the world, and sort of how do these things fit together. So this is very exciting. Still have a long way to go there to understand these things, but I'm excited to work with people who know it super, super well from all kinds of different angles, from the people who have actually been farmers that work here that I can talk to folks like Nell, who has this sort of scientific background and really understands the depths there. And I hope that, with the puzzle pieces that I bring to the table on the more technical side and the engineering side, that we can bring that together as something cool. And yeah, sort of what my team sort of plays the role here kind of as the foundation for a lot of the Indigo Carbon work of building the actual tools and software that enables the work of folks like Nell and others who work on the science side of things.
Amazing. And we are going to get into that in a second, but Stefan, I'm keeping you on the spot, and I want to ask you, what is your superpower?
What is my superpower? I don't know. I'm good at keeping many different balls in the air. I think that if anybody has ever called me on a superpower, it's probably that. Like when I was sort of younger and had not didn't have kids and free time and all those things, I could carry on a conversation with multiple people about different subjects at the same time. Like somebody sits to the left of me and somebody sits to the right of me, and I'm talking to both of them about different things at the same time. So maybe that's my superpower. I don't know. It's a pretty useless superpower, but
so it's okay. Nell, same.
Yeah. Oh gosh. Well, I tend to get excited very easily to talk about the nitty gritty of trying to get this thing off the ground. Yeah, I tend to get really enthusiastic, and I think it's a lot of fun to figure out how to get people who've never even thought about, modeling soils for carbon and greenhouse gas emissions, and figure out the way to connect them into the whole story. Because, my entry point is we all eat, and that food comes from somewhere. And so it's, it's like a nice straight shot from there into the technicalities. I find that a lot of fun.
At the very beginning. All right.
I like it.
There you go.
Actually, I want to throw in one more thing here, not superpower related, but sort of on the beginning on what brought us here. I think just to reiterate the point that Nell made about sort of finding a business that works on these things. Like I personally am, super passionate about environmental causes. I want, future generations to have a place that is as nice as this one, like just like being out in nature and things like that. And I've always thought about, what to do about that. And my wife once asked me after I joined Indigo if I care about these things a lot, why don't I join, Greenpeace or the Nature Conservancy or some organization that's really just purely about that. But really, ultimately, I think human nature just makes it really hard to trade off short-term concerns versus long-term concerns in a smart way without sort of incentives, right? That's just who we are, right? I still drive a SUV, admittedly a small one, but still. And, I run the AC, so it's not over 70 in the summer and things like that, right? It's just difficult. And I think the way to make this work, to make real change, is to make it economically viable, to make it a win-win, to do things that are better for the planet. And I really think sort of what Indigo Carbon is doing does that. It's a win-win. It's better for the grower. Ultimately, it gives us a way to draw down carbon that does not have sort of these negative, quote-unquote, side effects that require significant sacrifice on a large number of people. If anything, it's the opposite, right? If we're successful, farmers will have better crops and more crops while at the same time reducing, carbon in the atmosphere.
See, that was perfect. I don't think you knew you were doing this, but that tied directly into my next question, which is wonderful. So thank you, Stefan.
You're welcome.
For folks listening who don't know too much about Indigo Carbon, or frankly, what either of your teams do, what Indigo Carbon's trying to do, I'd love to take this chance for you guys to explain just kind of at a high level what the goal is there, what is Indigo Carbon, and also, you're both leading two different teams, so why do we have both of you on here at once, and how do you guys work together to make this all work?
Yeah, this isn't just a happenstance. There's a reason why you guys are
Could
here
be. I don't know.
I'm glad you just don't just draw names out of a hat and then talk to them.
I mean, maybe we should try that. It just sounds kind of
That could
fun.
be
But
interesting too, right?
all right, good idea. Coming up next.
Okay.
For now, though, tell us about Carbon and how you guys work together. What is this?
Yeah, maybe I'll take a first stab, and then I'd love to hear what you think, Stefan. But so the goal of the Indigo Carbon program is to set up a carbon crediting system that credits agricultural growers for implementing regenerative practices that reduce the net carbon emissions from their soils. So what that means is they are doing practices that increase soil carbon, so that you're basically using the mechanism of photosynthesis to take carbon out of the atmosphere, turn that into biomass, and increase the amount of that then goes and sits in the soil below ground. But also reducing what are called trace gas emissions, which is nitrous oxide and methane. These are two powerful greenhouse gases that are approximately 300 times and 35 times the impact compared to carbon dioxide. So about 300 times for nitrous oxide and about 30 times as much for methane. So the ability to both increase the carbon in soil and decrease these trace gas emissions reduces the net climate impact of agricultural soils and can be a very powerful mechanism for countering climate change while also increasing soil health, because having more carbon in your soils often leads to a number of other positive benefits in terms of soil fertility, water holding capacity, and that kind of thing. So carbon credits are this really exciting economic lever that exists because, there have been carbon credits that have been done in forested systems for a while, and a lot of learning that's happened through the years about how to do crediting in ways that are a verifiable source of positive impact on your net greenhouse gas emissions. And so our crediting program, the foundation of it is actually working with external registries for carbon crediting so that we have a protocol that we can use to generate carbon credits that has a third-party verification to it. So we're basically following best practices to make sure that what we're encouraging in the world is a true positive impact. But in order to do that, there aren't a lot of protocols that exist yet that do carbon crediting in agriculture because soils are incredibly complex. And there are a lot of different reasons why you change the amount of carbon that's in the soil or the amount of trace gases that are coming out of the soil. And so what really brought me to Indigo is the opportunity to, like Stefan was talking about, you have this program that is looking to create this economic incentive to have these positive impacts. But in order to do that, we need to put together some really clever approaches to using data technology and software development and these things that can basically help us pull together the data that are needed to have a positive impact, quantify it, and be sure that we're moving things in a positive direction. So stepping back, like that's kind of the overall goal of the program. And then within that, this really incredible group of people across many different dimensions on impacting agronomic practices and developing data technology and statistical approaches and developing the software behind actually doing this at a large scale, which is where I'll shift over to let Stefan fill in. But particularly within my team, it's this interdisciplinary group of scientists, mathematicians, and others that are coming together to basically help integrate the data sources, the methodology for carbon crediting, and the use of biogeochemical models, as well as taking direct soil measurements and pulling those all together to quantify credits and to then serve that out to a methodology to verify that the credits we've generated are valid. So it's pretty amazing. And my group and Stefan's group are working increasingly in concert to kind of do the science and the analyses, and then implement those changes in the software that are required to actually support this whole thing. It's pretty exciting.
I know. I feel like we need. I feel like we need
like, yeah, I feel like we need another hour to unpack a lot of this stuff.
Yeah, just to dive into basics of how the science works and how that fits into kind of an economic incentive model, and a whole podcast about it, really. Yeah.
A whole mini series.
There would be a lot that we could talk about, for sure.
Yeah.
I can already see the merchandise.
We're working on it. Yeah.
Get some good slogans going on some t-shirts.
Yeah. Stefan, talk about the other side of that marriage.
Yeah. So, I think sort of where we come in for the most part is as a complement to really make this a software business, because ultimately we need both. We need to have the scientific understanding to know what we need to do and how to, get the data from the fields and quantify what's happening to the carbon, what recommendations we can make to the grower, and so on. But we also need to be able to scale this. Right? We can't have scientists talk to every grower. We can't have, support people go to every farm. So our problem is sort of twofold on the software side. Is one, how do we scale this from a pure data perspective? Like, how do we run these systems so that we can do this for millions and millions of fields and tens of thousands of growers? And also, how do we make this as low intervention as possible? How can a grower come or a farmer come and just participate in the program in as easily and as low touch a way as possible? So that starts in the simplest case with just making systems that can run the models that Nell and her team come up with at scale, but extends to ways of bringing recommendations to growers in a seamless way through whatever tech platform they're most comfortable with, that can range from like complex web applications to just sending them an SMS with, hey, today's a good day to put your fertilizer on and whatnot. I'm making things up here. As as I said, I don't know anything about agriculture, but sort of how do we build these systems that can enable the science in a scalable way is really sort of where that comes together to me.
Yeah, and I think what gets really exciting from my standpoint in the technology and the development of software technology to do this is that the ultimate goal is that a grower has more resources to do more things that are great for where they are. And this is one of the key features of, for example, trying to increase carbon in your soils is that even field to field, you might have very different ways that you can go about doing that. And you need to consider a number of different complicated factors about, everything from your soil texture and where you are in the US in terms of your climate to, how was that piece of ground managed historically and, in near future and further back, and what could you do in that moving forward. So some very specific things that range in scale from, specifically what that soil is like to the climate that it sits in and the history of what happened there. So this is one of the interesting features of wanting to help growers know how to, manage to increase their soil carbon. It's something that there have been a lot of efforts to do this in the past, but generally, we didn't have the data resources to do it as specific as it needs to be per grower at a scale where lots of growers have access to what they need to have the right kinds of answers. So, in the past, what you would end up having is all this really great work coming out of academic institutions and research projects on looking at, for example, the impact of converting to no-till and modeling that and thinking about that more holistically on providing recommendations. But having the software and technology available to do it more dynamically is where, things get really exciting moving forward.
That was going to be kind of part of a question I wanted to ask is for you, Nell, of you've been in the academia side for a while and seen this, and what's so unique and from an a potential impact standpoint, right? Of the work that you do here working with the software side of the house, with your team. And, I know it's so tough to say, and we can really get excited about it, like everything. But I mean, talk quickly about that, like the uniqueness about the potential impact that this program could have.
I could talk about this for a long time.
Loaded question for you.
Yeah. Well, so I guess maybe I can quickly touch on two things. So one of the things that I appreciate the most about Indigo's approach is focusing on supporting a grower. Like the attention is towards how do we help growers have resources to benefit by these different practices, and essentially partner to bring science to growers in such a way that it becomes useful to them directly. Sort of the ultimate goal for all of this stuff, and a lot of really great work and research and extension, and like there's a lot to draw on for trying to achieve this objective. And I feel like Indigo both has a grower focus and is very strongly connected to making good use of science. So, drawing from recommendations and having connections to government agencies, and, this goal of increasingly working with academic researchers and having strong connections to the scientific community, so that we're sort of working more and more towards this ideal goal of forging another connection to growers that is useful. So that's one dimension of it, but I of course get very excited about the scientific side as well. We have the teraton experiments and that dimension that has good connections with the scientific community already, but the capacity to build out on that and to be partnering with the scientific community as we gather data sets and gain understandings of what's going on in commercial agricultural systems. Because you think about how academic research is typically done, you don't necessarily have wide-scale access to commercial agriculture, where tromping around and digging soil pits in the ground aren't necessarily something that work into the commercial calendar necessarily. So to have the ability to both kind of be working on gaining understanding in this through time, I think there's some really, really exciting potential for good science as well. And that's a dimension that I look forward and hope to expand on, or hope that the company as a whole gets to expand on as we move forward with this.
That's why we brought you here.
Yeah.
That's why we stole you from academia. Sorry. But Stefan, so let's talk about data, and let's talk about the complexity of what you guys are working with on your team, from in terms of scale challenges that can get hardcore engineers excited about it, right?
Mm-hmm. Really, lots of things. I feel like we're just almost drowning in interesting things to do. From just dealing with, I'm just going to give you a few examples out of many, many, right? From just sort of dealing with the complex geometries that fields come in, right? We need to understand what are the boundaries of fields, and how do we deal with boundaries of fields over time, and how do we build systems that are flexible enough to deal with these complex geometries, and apply data and track data around those.
Paint the picture of the satellite images of all the fields of each farm, right?
Yes. Yeah.
And
they can change over time, right? Maybe there's some erosion, maybe a tree fell over and fell into your field, and then you need to update data and so on. Like, how do you have systems that are flexible enough to sort of cope with these things? That's sort of more an algorithmic complexity problem, but we're also dealing with millions and millions of fields eventually. So there's an interesting scale there. One of the data sources we rely on very heavily is satellite data. So we take data from ESA and NASA satellites. That's usually sort of broad spectrum imagery, so it goes into infrared and things like that, and process that. There's sort of interesting problems on how you transform that data. How do you deal with gaps? What do you do if there's a cloud in the way of the field that you're trying to take a picture of? How do you deal with sort of those things? And the data volume there is incredibly large. We're dealing with many, many terabytes of data a day, going into the petabytes if you look at across seasons and things like that. And how do you build systems that can do that efficiently without breaking the bank? Indigo is still a startup, so we can't just throw money at the problem. We actually have to think through how can we design systems and algorithms that can do these things at scale in an efficient manner. Then sort of the scientific side, how can we take the science that's still evolving and build things in a way that's flexible and dynamic enough that we can move quickly and then adjusting these things. And I got to say, just sort of riffing back to the operating model, like I'm super happy and super excited that we have actually the scientists here with us who understand these things. I've been in a position a couple of times in my career where we essentially build systems based on scientific research, but usually the access was, oh, we have a paper and we need to build the thing that's in the paper, and maybe we can email them and they'll get back to us in 3 weeks. Versus now actually sort of being almost joined at the hip here with, you know, leaders in the field on the scientific side to understand these things. It's super exciting.
Awesome. All right. I know we're out of time. How are we going to wrap this thing up?
Oh man. I mean, I think it's pretty safe to wrap up there. And then we'll hold a part 2 as quickly as possible, because we have a lot of things we got to unpack in terms of like what each of your team is really diving into, right? Because we just scratched the surface at a high level. So we need to get one on the books, and I'm going to do it. We're going to do it today so we don't drag this out a couple weeks. But I think let's pause there. And this is wild. It's so fun to think about.
All right.
Cool.
I agree. It's very easy to get excited.
You warned us.
I know.
Now you got the bug too.
Exactly.
The hooks have been in. It's right. Where, as Ophir would say, which you'll see, it's drinking the Kool-Aid. It's there. It's there. Well, yeah. Well, thanks for joining us, guys.
Thank you.
Thanks for having us.
Yeah, thanks a lot.
Until next time.
Thanks.
We'll see you soon.
Bye.
Bye.
See ya.